All right, everybody, welcome back. I'm going to go ahead and get my screen share rolling. Welcome back. So just wrapping up the new problem here. And again, we're working with averages. And I think a lot of times when we are working with averages, there's this fear factor that goes from the simple addition, subtraction, multiplication, division to something that might have some unknowns attached to it. Unknowns always make us uncomfortable. I was talking to somebody yesterday who said, the unknown makes me uncomfortable. So I'm going to try to kind of work through that and get us over our fear of delving into things that we have to solve for or don't come as easy as we would be thinking. And a lot of times we run into a situation where we have incomplete information. So the other thing is, the next part of this is making a stretch into making assumptions about math is a lot harder than just simply having the problem lay out for you and then actually regurgitating what you've been taught memorization wise. And I share with you that memorization does not have as much worth in 2023 as it did in previous years, because a lot of the memorization we could just throw into a spreadsheet, which I'll be doing here in a moment. And also, it just doesn't bring as much value as actually being able to apply. Now, applying is just like working out. The first time you do it, it hurts, it feels uncomfortable, but the more you try to set these things in motion, even if you make mistakes, don't be afraid of mistakes, you're going to get better outcomes. So let's go ahead and look at this problem. The teacher giving a 20-point exam, I won't get into a big lecture, to a class of 20 students. And the question is it possible for 19 of the 20 students to score above average on the test? So in order to give you a little more context, and this is a little further than your book, I popped in a bell curve. I actually borrowed this from study.com. Study.com, I apologize. I did not have time to go to Creative Commons. My bad. But I wanted to take a moment to talk to you about what this bell curve means. So I'm actually going to go in, I'm going to run over here to Excel. It's green too. I'm going to double check and see that my screen one is actually sharing. And I'm going to show you an instance of all of the students. So what I did is I actually put in all the different grades. Now, you could have a test out there where the students are like, what color is the sky, right? Blue. Well, hopefully the students could recognize color. There may be a language barrier or something to that effect, but this is a very easy test. So you could just give a very easy test and have all the students score a 20 on the test. And then let's say maybe one student doesn't show up to class or accidentally selects the wrong box and puts green instead of blue. Maybe they think too much. So even in that circumstance, when we add all the instances together, which I did, and I got 380, and I'll show you my formula that I did. Now, oops, you're not expected to do Excel formulas in this class, but I show you this just in case you're ever in that situation where you're teaching a class yourself and you're like, oh, I'd like a shortcut. You know, this is one way that you can add all the numbers together. And that sum function will add all your scores together. Now, the next thing that we look at is, can the student score above average? So if we go back over here to my, and again, I want to make sure I'm screen sharing, so I'll just go ahead and double check it. If we go back here to my original plan right here with the bell curve, you can see some percentages here. So 34.1%, 31.4%. This right here in the middle is indicative of a normal average score on a bell curve. If your scores follow a normal distribution. If they don't, we have other issues, which is the test was too easy, the test was too hard. But in this case, we have a kind of a normal curve. So let's go ahead and add these two percentages up. This is a little bit up beyond the scope of the class, but I just want to give you this extra info, 31 point. Let's just leave the 0.4 up, 31.1. 34.1. We add these together. I'm just going to click on the boxes to add them together. That's 68.2. And then I'm just going to multiply it times 0.01 to convert it to a percent. Let's make it into a pretty percentage right here. So 68% of the students, right, should be scoring an average score. And then I said, well, what is an average score? And I actually did this math already for you. I'll make it nice and big too, because if you're like me, you're probably struggling with your glasses. The average score is somewhere in the 70%. That's usually the norm for teaching, right? 70%. That's kind of in the middle, right? C, right? C plus, depending on your grading curve. So the average should be around 14. So if 68% of the students score 14, then this would be in the average. So if we look at this, these scores are obviously above average. So going back to the problem right here, which is it possible? And a lot of times, is it possible is a very good problem because it's not asking for a defined answer. It's saying, can we do this? The answer to this is yes, it's absolutely possible. Now, I don't want to give the entire farm away here, but take a look at the part 2 using the information that I provided and see if you can walk your way through it on your own. I think that with a similar problem, it should be pretty intuitive. Again, I say don't be scared of ambiguity. Don't be scared of anything at all. You can do this. Math is fun, math is insightful, and math is the future. Have a great rest of your day, and I hope you're enjoying these problem sets.